Hello class 8 students, welcome back to the Science Digital class. Today we are going to start chapter 11 of Art Science textbook, which is Sound. Chapter at a glance. Sound. Sound is produced by a vibrating body. Musical instruments. How we hear the sound. Types of sounds. Musical sounds. Sound needs a medium for propagation, noise and music. Engage. We hear different types of sound from morning to evening. Some sounds are pleasant to our ears while some are not. Below are given some sounds. Write pleasant or not pleasant against them. तो इन पिक्चर्स में कुछ साउंड्स दिए हुए हैं. ये हमारे कानों को प्लेजेंट लगते हैं या नहीं, ये हमें इनके सामने लिखकर बताना है. Let's start the chapter. Sound. We hear various types of sounds around us, such as horn of vehicles, loudspeakers, shouting, etc. At times, we may hear buzzing of bee, rustling of leaves, chirping of birds, etc. Types of sounds. Sound is a form of energy which excites in our ears the sensation of hearing. Some sounds like that of whistle are shrill, while others such as the beating of drums are dull. Some of them like the sound of thunder are loud. Others like the rustling of leaves are soft. Some sounds such as that produced by a guitar are pleasant, while others such as the sounds produced by a drilling machine is unpleasant. Each sound has its own characteristics. It is because of these that we can recognize different sounds. तो साउंड जो होती हैं वो डिफरेंट टाइप्स की होती हैं. हर साउंड का अपना एक कैरेक्टरिस्टिक होता है और उन्हीं कैरेक्टरिस्टिक्स की हेल्प से हम उस साउंड को पहचान सकते हैं. कुछ साउंड्स हमें अच्छी लगती हैं और कुछ साउंड्स हमें अच्छी नहीं लगती. Ringing the bell, we come to know that a period is over in our school. Hearing the sound of a doorbell and knock at the door, we come to know easily that someone is at door. Sound plays an important role in our lives. It helps us to communicate with another. We hear a variety of sounds in our surroundings like bus, helicopter, aeroplane, band, etc. In the music room of our school, we hear the sounds produced by musical instruments like flute, tabla, harmonium, etc. Sound is produced by a vibrating body. तो sound कैसे produce होती है? जब भी कोई body vibrate करती है, उससे sound produce होती है. As we note that the to and fro motion of a vibrating particle about its mean position is called an oscillation. But sound is produced by vibrations in a body. Drive a nail into the wall or any flat wooden surface. Tie one end of a rubber band to the nail and pull the other end. Plug the rubber band from the middle. Does it produce a sound? In this picture, you can see rubber produces sound. What kind of motion do you observe in the rubber band? तो इस छोटी सी एक्टिविटी को करने के बाद हमने रबर बैंड में कैसा मोशन देखा? Let's see. We'll see the rubber band starts vibrating as shown in the figure. Simultaneously, you will hear a sound also. Thus, it clearly proves that a sound is produced due to vibrations. When it stops vibrating, it does not produce any sound. The wires of a guitar also vibrate when we plug them. The wires appear hazy while vibrating. Touch a bell gently while it is ringing. Do you feel the vibration? When we strike pan with a spoon, it starts vibrating, and when we touch it gently, we feel the vibrations. When we strike the pan again with the spoon and hold it tightly with our hands immediately after striking, we hear the sound. When we touch the pan after it stops the producing, we do not feel vibrating because when pan stops vibration, it does not produce any sound. Thus, we see that a vibrating object produces sound. In some cases, the vibrations are easily visible to us, but in most cases, their amplitude is so small that we cannot see them. However, we can feel them. Let's start musical sound. Continuous vibrations produce musical sounds, whereas discontinuous vibrations produce noise. However, this is not all. Listen to the sound produced by a tuning fork and the sound of the same fundamental produced by a sitar. The tuning fork sounds flat, whereas the sitar sounds rich. This is because the sound produced by a tuning fork has only one frequency. It has no harmonics. The sound of a sitar has a number of harmonics. Thus, harmonics give richness, that is, musical quality to the sound. तो किसी भी साउंड के म्यूजिकल होने के लिए उसके अंदर हार्मोनिक्स होना जरूरी होता है. Musical instruments. Musical instruments use vibrations of various kinds to produce music. Depending on the kind of vibrations produced, they are of three types: stringed instruments, wind instruments, percussion instruments, stringed instruments. Let's start first with stringed instruments. In string instruments, music is produced by vibrating a string. When the strings are plucked, struck or played with a bow, as in violin, they vibrate to produce a musical sound of some particular frequency. The pitch of the sound can be changed by altering the thickness, tightness or length of the wires. For example, in a sitar, the shorter the length of the wire, the higher the pitch it produces. Violin, veena, sarod, sitar, guitar, etc. are the examples of stringed instruments. Here in this picture, you can see veena. Wind or reed instruments. Wind instruments use vibrations in air columns to produce sound. Holes in flute, for example, are opened or closed in order to change the length of the vibrating air column. By changing the length of the vibrating air column, we can change the pitch of the sound. Flute, shehnai, clarinet, bugle and mouth organ are the examples of wind instruments. Here in this picture, you can see shehnai. Knowledge basket. When we pluck a string of guitar, the body of the guitar also vibrates along with the string. The sound we hear is therefore not just of the string but the whole body of guitar. Short column produces sound of higher frequency. This concept is used in Jal Tarang. The bowl which has more water has shorter length of air column. Such a bowl produces sound of high frequency. Percussion instruments. Percussion instruments have a stretched skin whose vibrations produce sound. Loudness is increased by striking the skin harder. The pitch is increased by stretching it more. Dholak, drums, bongos, tabla, mridangam are the examples of percussion instruments. Besides above, some more instruments are commonly used in many parts of our country like manjeera, cymbals, ghatam, nut, mud pots and kartal. Sound produced by humans. Humans के द्वारा जो sound produce की जाती है वो उनके larynx से आती है. Let's see it. The larynx is the body's voice box. Put your fingers on your throat and find a hard bump that seems to move when you swallow. This part of body is known as the voice box. Here in this image you can see a larynx in humans. It is at the upper end of the windpipe. The voice box has two vocal cords. They are stretched across the voice box in such a way that it leaves a narrow slit between them for the passage of air. When we speak, lungs force air through the passage due to which the cord starts vibrating and produce sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type and quality of voice is different from that when they are loose and thick. With the help of the following activity, let us see how the vocal cords function. Women have shorter vocal cords than men. Children have very short vocal cords. That is why the frequency of sound produced by women and children is of higher frequency than sound produced by men. Characteristics of sound. Loudness. जो sound के जो कुछ characteristics होते हैं उनमें से one है loudness. If you strike a drum softly, it produces a soft sound. If you strike it hard, it produces a louder sound. In the other words, in the first case, vibrations with small amplitudes are produced, and in the second case, vibrations with large amplitudes are produced. This shows that the loudness of a sound depends on the amplitude of vibration. It is measured in decibel, dB. Loudness of sound is expressed in the units of decibel, dB. Some sounds and their decibel is as follows. Normal breathing 10 dB, soft whispering 30 to 40 dB, talking 30 to 40 dB, teacher 40 to 50 dB, radio or TV low 40 to 50 dB, moving car 60 to 70 dB, motorcycle 90 to 100 dB, factory 80 dB, thunder 125 to 150 decibel, 10 jet planes above 150 decibel. Let's start the pitch, the other characteristic of sound. Drive a nail into a wall, the one end of rubber band to the nail. Now stretch the rubber band only slightly and strike it. It will produce a dull sound. Pull it hard and strike it again. A more shrill sound will be produced. Observe the vibrations carefully in the two cases. You may be able to make out that the rubber band vibrates faster when producing a shrill sound than when producing dull sound. The shrillness or flatness of a sound is known as pitch. The pitch of a sound depends on the frequency of vibration. The higher the frequency of a sound, the higher will be its pitch. तो जो पिच होती है वो फ्रीक्वेंसी के ऊपर डिपेंड करती है. अगर फ्रीक्वेंसी हाई होगी तो पिच भी हाई होगी और अगर फ्रीक्वेंसी लो होगी तो pitch low hogi. A woman's voice generally has higher pitch than a man's voice. This is because the frequency of women's voice is higher. The thinner wires of a guitar or sitar gives out sound of higher pitch than the thicker wires. The thin wires vibrate with greater frequency than the thick wires. Also, a guitar wire vibrates with higher frequency if tightened further. This is true for the skin of a tabla also. If you tighten the skin, it produces sound of higher pitches. तो गिटार की वायर को अगर टाइट कर दिया जाए तो उनसे हाई फ्रीक्वेंसी साउंड प्रोड्यूस होगी. इसका मतलब जो साउंड होगी वो ज्यादा लाउडर होगी. एंड दिस इज द सेम ऑल्सो विथ तबला. अगर तबला की स्किन को टाइट कर दिया जाए तो उससे जो साउंड प्रोड्यूस होगी वो हायर पिच की होगी. साउंड नीड्स अ मीडियम फॉर प्रोपगेशन. Sound is a form of energy and is produced by a vibrating body. The vibrating body transfers its energy to the neighboring molecules in the medium, which in turn pass on their energy to other molecules. The mode of travel of the sound from place to origin to the distant places is known as propagation of sound. तो जो साउंड है उसको ट्रैवल करने के लिए एक मीडियम की जरूरत होती है. जो वाइब्रेटिंग मॉलिक्यूल्स होते हैं वो अपनी एनर्जी अपने पास वाले मॉलिक्यूल्स को ट्रांसफर करते हैं और वो अपने पास वाले मॉलिक्यूल्स को, और इसी तरह से जो साउंड है वो अलग अलग जगह तक ट्रैवल कर पाती है. साउंड नीड्स अ मटेरियल मीडियम लाइक सॉलिड, लिक्विड एंड एयर टू ट्रैवल एंड बी हर्ड. साउंड ट्रैवल्स इन वेव्स. तो साउंड जो है उसको मीडियम के लिए सॉलिड, लिक्विड या फिर एयर की जरूरत पड़ती है जिससे कि वो ट्रैवल कर सके. साउंड नीड्स एयर फॉर प्रोपगेशन. टेक अ मेटल ग्लास, मेक श्योर इट इज ड्राई, प्लेस अ मोबाइल इन इट. आस्क योर फ्रेंड टू गिव अ रिंग ऑन दिस मोबाइल फ्रॉम अनदर मोबाइल. लिसन टू द रिंग केयरफुली. नाउ surround the rim of the glass with your hands. Put your mouth on the opening between your hands. Now indicate your friend to give a ring again. Listen to the ring while sucking air from the glass. Does the sound become fainter as you suck air? Remove the glass from your mouth. Does the sound become loud again? Can you think of an explanation? Indeed, if you had been able to suck all the air in the glass, the sound would stop completely. Actually, sound needs a medium to travel. When air has been removed completely from a vessel, it is said that there is a vacuum in the vessel. The sound cannot travel through a vacuum. Sound therefore requires a medium to travel. Here in this picture, you can see sound need a medium to travel. Knowledge basket. Heinrich R. Hertz, 1857 to 1894, a German physicist, discovered the electromagnetic waves and used them in the development of radio, television, and radar. He made use of an electric spark to produce waves of very high frequency. SI unit of frequency, Hertz, is named after him. How we hear the sound? We hear the sound through our ears. Our ears are sensory organs that help us to hear sound. Only one of its parts can be seen and felt by us, that is the outer ear. The rest of the delicate ear is buried deep inside the skull. In this diagram, you can see a human ear and its all the parts. The shape of the outer part of the ear is like a funnel. The outer ear catches sound and sends it to the middle ear. The middle ear has the eardrum. When the sounds fall on the eardrum, it starts vibrating. These vibrations pass on to the inner ear. From here, the nerves send the message to the brain. That is how we hear. Audible and inaudible sounds. कुछ साउंड्स ऐसी होती हैं जिन्हें हम सुन सकते हैं और कुछ साउंड्स ऐसी भी होती हैं जिन्हें हम नहीं सुन सकते. Our ears can only hear sounds with frequencies ranging between about 20 Hz to 20,000 Hz. This is called the audible frequency range of sound. Such vibrations are called sonic vibrations or sound vibrations. Low frequency sound less than 20 Hz which we cannot hear are called infrasonic objects that vibrate at frequencies of above 20,000 Hz produce sounds which also cannot be heard by us. Such sound are called ultrasonic. Human beings cannot perceive either infrasonic or ultrasonic sounds. Hence, these are called inaudible sounds. That is, sounds we cannot hear. Thus, for human ear, the range of audible frequencies is roughly between 20 Hz to 20,000 Hz. Amplitude, time period, and frequency of a vibration. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. Show the pendulum of rest in its mean position. When the bob of the pendulum is released after taking it slightly to the one side, it begins to move to and fro. Here in this picture, you can see how simple pendulum moves to different position of the bob of an oscillating simple pendulum. The to and fro motion of an object is known as vibration. This motion is called oscillatory motion. The number of oscillations per second is called the frequency of oscillation. Frequency is expressed in Hertz. Its symbol is Hz. A frequency of 1 Hz is 1 oscillation per second. Amplitude. If you give the ball a small push, the oscillation of the ball about the control position are small. If you give the ball a strong push, the oscillations are longer. The distance by which the ball moves away from its central position is called the amplitude of the oscillation. Thus, the maximum displacement of the bob from the mean position during oscillations is called amplitude of the oscillation. In the case of simple pendulum, as shown in figure, the amplitude is AB or AO. Time period. The pendulum is said to have completed one oscillation when its bob, starting from its mean position O, moves to A, to B and back to O. The pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position B and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. Thus, the time taken by a vibrating body to complete one oscillation is called the time period. It is difficult to measure the time for a single oscillation. Therefore, we measure the time taken for 10 oscillations and divide the total time by 10. It will give us the time taken for one oscillation. Also, if we measure the time several times for different amplitudes, we will find that the time for one oscillation remains the same no matter what the amplitude. Frequency. Scroll. If we count the number of oscillations of a pendulum in say 60 seconds and divide the number by 60, it will give us the number of oscillations per second. This is called the frequency of oscillation. For a pendulum of given length, the frequency remains constant. Frequency is denoted by the letter F. The unit of frequency in SI system is Hertz, Hz or S. When a vibrating body produces 20 vibrations, oscillations in 1 second, its frequency is said to be 20 Hz. If the frequency of a counting fork is between as 200 Hz, it means that it produces 200 vibrations in 1 second. Relation between time period and frequency. Time period is denoted by the letter T. If F is the frequency and T is the time period, then F vibrations are completed in is equals to 1 second. Therefore, one vibration is completed in 1 by F. We know that the time taken to complete one vibration is its time period T. So, T is equals to 1 divided by F or time period is equals to 1 divided by frequency. Noise and music. We hear different types of sound from a variety of sources around us. Some of these sounds are pleasant to the ears while some are not. Sound that is pleasant to our ears is called music. A sound that does not sound pleasant to our ears is called noise. तो जो sound हमारे ears को pleasant नहीं लगती, हम उसे noise कहते हैं. Suppose construction work of a building is going on in our neighborhood. Are the sound coming from construction site pleasing? Do you enjoy the sounds produced by horns of scooters, bus, truck and train? Perhaps no such unpleasant sounds are called noise. If all the students in a classroom speak together, the sound produced would also be called noise also. On the other hand, we enjoy sound from musical instruments. Suppose a marriage function is going on in our neighborhood. We enjoy the sound produced by musical instruments. Thus, musical sound is one which is pleasing to the ear. Sound produced by a harmonium is a musical sound. The string of a sitar also gives out a musical sound. But if a musical sound becomes too loud, would it remain be melodious? No. And then it becomes noise. Noise pollution. We know about air pollution. Presence of unwanted gases and particles in air is called air pollution. Similarly, presence of excessive or unwanted sound in the environment is called noise pollution. Too much noise in our surrounding is harmful to us. Automobiles, buses, heavy machines in factories, loud uproar from religious, cultural and political gatherings, rock bands, loudspeakers, etc. are the main causes of noise pollution. Television and radio or transistor at high volumes, some kitchen appliances, desert coolers all contribute to noise pollution. Knowledge basket. An object that travels faster than sound is said to have supersonic speed. Such objects produce shock waves while traveling with supersonic speed. The sound produced by these waves is called sonic boom. Harmful effects of noise pollution. Presence of excessive noise in the surrounding may cause many health-related problems. It can cause irritability, loss of concentration, high blood pressure, headache, stress, sleep disturbances. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. Measures to limit noise pollution. To control noise, we must control the sources of noise. We must follow the following. First, silencing devices must be installed in aircraft engines, transport vehicles, industrial machines, and home appliances. All noisy operations must be conducted away from residential areas. Noise-producing industries should be set up away from such areas. Use of automobile horns should be minimized. Television and music systems should run at low volumes. Reducing noise emissions by developing low-noise products, for example, low-noise automobiles engines. Control over recreational noise such as use of loudspeakers. Trees must be planted along the roads and around buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution. Increasing public awareness of noise by providing factual information of the effects of noise such as blowing horns, playing loud music and TV, etc. with a view to influencing behavior to avoid noise generation. Above given measures can, however, only be succeed if supported by the public. Tech Talk. Digital Signal Processor. A digital signal processor, also known as DSP, is a device which converts analog audio to ones and zeros for use in digital environment. While DSP aren't necessarily a new thing, there have been advancements within this technology that make today's DSPs far superior to those of even the recent past. The most notable of these changes is the resolution. Moral learned. Sound pollution is an invisible danger. It cannot be seen, but it is present nonetheless, both on land and under the sea. Noise pollution is considered to be any unwanted or disturbing sound that affects the health and well-being of humans and other organisms. Recapitulation. Sound is produced by the vibration in a body. In human beings, sound is produced by a voice box or the larynx of our throats. Loudness of a sound depends on the amplitude of vibration. The frequency is expressed in hertz, Hz. More trees planted on the roadsides to act as noise buffers. Thank you class. Let's meet again in the next chapter.